Hello class. In this short video, I'm gonna clarify maybe a couple of problems that I observed in mathXL in which you had problems in the last lesson, okay? And as you may remember, it was this problem in particular, this exercise. Many of you had problems doing it. So let me explain to you how to do this problem. Uh, so what are we talking about here? This is a division of polynomial over monomial. Can you see? Okay. So, in broadly speaking, this is no different at all from, say, performing this division. Suppose I give you this division. Okay, we have a polynomial over a monomial. Sorry, I forgot the x. Yeah, and basically we have to divide the whole polynomial and divide each of these terms over 2x independently. Do you remember? So it will be like this, 6x squared over 2x, and then plus, because we have a plus here, and then 8x over 2x, and then minus, because we have a minus here, minus 14 over 2x. And then independently, you carry out each of these divisions of monomials, monomial over monomial, which are very simple, and you're done, right? I'm gonna do just the first one. This is gonna be 3 and x, and you continue with the rest and you're done. Okay, this problem is no different than this. Conceptually speaking is no different. What is the source of the confusion? The source of the confusion for your mind is that what you observe here are exponents, which are variables. Okay, you see the n. Can you see the n? This exponent is n plus 1, n minus 1, n minus 2, n. And this is what is causing you some confusion. Okay, so what do we do? Like I said before, this is no different than the example that I showed you a moment ago. So I'm going to do exactly the same thing. Look. And by the way, your confusion, I mean, if you had a confusion in this one, is understandable and it's very common. Okay, so the first thing I'm gonna do is the same. I'm gonna divide each of the terms of this polynomial over the divisor, which is this monomial. So I'm just gonna write it down like so. 12x raised to its proper exponent over 3 times x to the n. Then we have a plus. Okay, so I'm gonna keep going and observe, make sure that I'm doing it right. Just confirm. So this is the first thing you have to do. Okay, perfect. And like I said a moment ago, now all you have to do is perform each of these divisions, monomial over monomial, monomial over monomial, monomial over monomial, the same here, on its own, independently, one from the other, and then you get the answer. Now, uh, this is very important, pay a lot of attention. You don't have, in mathematical problems, the variables are numbers, guys. There is no difference at all. If I do this, for example, x to the, let's say x to the s over x, that's an s. Well, let me write another thing because it's going to get confused with a 5. X to the a over x to the 3. You may be thinking, okay, how do I perform this? Because I don't know what number a is. And you're right, you don't know what number a is. But the fact of the matter is that it is a number, okay? Even though you don't know what number it is a number. And all the algebraic laws and the theorems and the axioms and all that stuff that we have seen are applicable to these things, okay? It's no different. If you remember, we have this law. I'm going to write it in red. or pink. I don't know what color this is. We have this law, guys. Remember, a to the m over a to the n is equal to a to the m minus n. What are m and what are n? They're numbers. Okay, they're numbers. So just apply this law to this problem. What would be the solution? Okay, the solution would be that this is equal to x raised to this exponent a minus this exponent 3. And you're done, guys. This is the answer. You see? Don't what I'm trying to say is this: don't expect these exponents to always be constants. They can be variables. There is no, basically at the basic understanding, there is no difference between a variable and a constant. The only difference is that the variable is a number that you don't know yet. That's the whole difference. I do not want you to look at these things and think that they are letters. They are not letters. These are numbers, okay? This is a number, this is another number, etc. The difference is that you don't know what number it is, okay? It's an unknown number. But other than that, they're numbers, guys, okay? And this is the problem in junior high and high school, that your mind tries to assimilate this as a letter, as if, como una letra. But they're not letters, they're numbers. They are numbers. I'm going to give you another example of what I mean. Okay, erase this. Suppose I give you this small division. What if I tell you divide x raised to the a minus b, this is the exponent of x, over x to the 2 plus c to the square. Okay, I know it looks complicated. I know, I understand that. I understand. But it's no different than this. What is the exponent of x? It's all of this, a minus b, which is a number, right? All of this in the end will be a number, because the subtraction of two numbers is a number. And all of this is the exponent of this x below 2 plus c squared. I know it looks complex, but in the end it's just a number. You see what I mean? And if I want to perform this division, I help myself with this law that says a raised to a number over a raised to a different number is equal to a raised to the first exponent minus the second exponent. That's it. Just follow the law as it is. Like just follow it blindly, so to speak. So what would be my answer in here? My answer would be x raised to the first exponent, which is all of this, you see, minus, and by the way, I think a parenthesis would be very advisable here. This is all the first exponent minus the whole second exponent, which is all of this. And I need to put that in parentheses too. You see? X raised to the first exponent, which is all of this, minus the second exponent in here, which is all of this. And we are done, guys. This is your solution. There is no mystery about it. Okay, so I'm gonna perform just very quickly this division of monomials very quickly with these ideas in mind. Let's perform it. The division of the coefficients is very simple. It's just 4, and then you have x to the n plus 1 over x to the n. I'm gonna do that in here. X to the n plus 1 over x to the n, and I just apply my law. This is gonna be equal to x to the first exponent, which is n plus 1, minus the second exponent, which is just n. And at the end, if I can simplify this exponent, I do it. N plus 1 minus n. In the end, the n's are going to be canceled together. Can you see? Because one is positive, the other is negative. And you're going to be left with x to the 1, which is just x. So all of this thing goes down to 4x. You see? That is how this works. this is no different than any other division of polynomial over monomial that we have performed. The fact that they have variables in exponents do not really change the process or anything. Try to understand very well what I just said, and if you have still questions, ask me. I know it's difficult to understand these things. This is your first major understanding of mathematics. Okay, you're transforming your brain into more abstract thought, but you have to make a big effort. Okay, so I'm gonna do the other. I said there were two exercises that I want to comment. I'm gonna just keep this one for the moment. Okay, I'm gonna stop it right here.